Okay. So yesterday we discussed about the OSPF. Okay. So for the OSPF, see, uh, if you want to, okay. So whenever we look for any configuration or anything, see, just like see nowadays we have a packet tester, but before that, the before packet tester, like in 2005, 6. So we used to do on the notebook. We used to do the practice on notebook. So like for example, the commands. Okay, the commands will be like uh, show IP route. This command is to check the routes. Check. Okay, then if I go to if I want specific, show IP route RIP. This will show you only the route which learn from the RIP. Similarly, show IP route OSPF, right? So in RIP, we have seen one more command. Show IP, IP, show IP RIP database. So it will show you the database. Okay, similarly, for OSPF, show IP OSPF neighbor. This is one command we have seen. It will tell you the neighbor. Similarly, show IP OSPF topology. Is it right command? Topology. Show IP OSPF database. Oh, sorry, database. Similarly, show IP RIP. Put the question marks in database. So two things. For the RIP, see, if you put the show IP route, it will tell you the global routing table. But if you want to go specific, show IP route question mark. See, so you will see the if you want to see the connected. What are my connected routes? These are my connected networks. What are the route came from OSPF? Just put the OSPF. You will see the OSPF. So that's the one. So okay, and see in the OSPF. Yesterday, I think I missed few things. Okay, so in OSPF, when the hello packet, see, whenever you configure OSPF on the routers, what will happen? The router initiate the what is called hello packet. First, they will send a hello packet. So in the hello packet, there will be this content will be there: router ID, hello ended interval, neighbors, area ID, router priority, DRP, BDR IP address, authentication, subnet mask. So this thing will be in the neighbors. Then see when the neighbor before the neighborship is established. So there are some steps. The first thing, router A and B, when you configure the OSPF, that time they will be on the down state. Okay. The next state will when you configure the OSPF. Similarly, one router will send. I am router ID. My ID is this one. I see no one here, and it sent this on the broadcast IP address. Sorry, multicast IP address 224.0.0.5. Right. So similarly, when this packet receive to router B, it will send I am router ID 5.2 and I see 172.168 16.5.1. It is on my left side, and it is connected. It is my in my neighbor list, and it is connected via Ethernet 0 by E0. So when they understand each other, okay, there is some OSPF on my neighbor side, so it will be a two state. It is called a two-way state. Then what will happen now? Once the state become, so what will happen now? This router will say, I will start exchange. Exchange because I have a router ID. So now there is one thing called router ID. Yesterday I missed to tell this about router ID. So in OSPF, when you say show IP OSPF neighbor, so see there is something called, see I'm in the UK router. I'm seeing like for the USA router I'm seeing 20.1. So if you go here 20.1, see 20.1 is nothing but one of the interface of your router, USA router. Show IP interface brief. See, so 20.1. So why the 20.1 become router ID? Why not this one? Why not this one? So the answer is, the first thing, if you have three interfaces. So out of this interface, the higher number will take become a router ID. Higher number. If you see here 192.168 1 dot, this is a smaller one. 2 dot, it is a smaller one. 20 dot, it is the highest one. That's why it become a router ID. So there is another option. If you have a loopback configuration, let's say I'm just see in USA router I'm creating one loopback. Loopback one. Okay. IP address 192.168. Sorry, 192.168 dot. Let's say 30, not 30. 100 dot 100. 255 dot 255 dot 255 dot 0. I created this one. And what I need to do next? I need to advertise that route in my router OSPF one. How I will do? Network 192.168.100.0, then wildcard mask 0.0.0.255 area 0. Right? I done that. So now if I go here, see, uh, previously what it was saying, show IP SPF neighbor on and this one. So okay, show IP route. Check the route. Show IP route OSPF. I got that route. That route got advertised from the US router. Okay. IP SPF neighbor. Let me shut down this one. So IP interface fast Ethernet 0 by Giga Ethernet. Giga Ethernet 0 by shutdown. See, when I shut down, so neighborship will down automatically, because what I did, I just shut down this interface. So will UK router have the routes of Hyderabad network? Can you tell me the answer fast? When the neighborship down, can you answer me please?
No.
No, because the link is down. So
Exactly,
No.
because see, Hyderabad, sorry, India network, it is not connected, directly connected. So only via routing protocol it should come. So what happened? This route is actually had with the USA route network. Okay. So now it has the dependency. Now if this link went down, so this network completely got isolated. Even this guy might have okay, now this guy, if you check its routing table, show IP OSPF route. Show IP route OSPF. Can you see we lost that 30.0? Previously it was there. So IP OSPF neighbor. So now if I make it no shutdown, no shutdown. So once the link up, see, the first thing first, the neighborship will come up. Show IP OSPF neighbor. Okay, neighbor came. See, currently it is in two-way state. Can you see? Two-way state, two-way state. When it is a full state, then the neighborship will completely become. show IP OSPF, show IP route OSPF. Currently there is no OSPF. Can you see? Even after we enable the route interface, still it is there is no OSPF route. Why? Because show. Okay, now can you see? Now the neighborship become. So now if I check this command, now see all the routes came. And when I see neighbor, can you see? Now state is full. So what is mean? Stateful means, see, when it was in the two-way state. See, two-way state means what? When we saw two-way state means both router was fighting. Both router was fighting that uh, I want I will exchange because I have a router ID, bigger router ID. He will say I have the router ID. Okay. So now what will happen? The election will happen in the extract state. One will become master, one will become slave. Okay, then one guy will send, okay, here is my LSB, all my link state database, here is my link state database. once they send once they send, now both will say thank you for the information. Now they are in loading state. Now I need to complete entry of network. So now LSR, see, LSR is link state LSR packet, and this is LSC packet. So these are very detailed stuff about the OSPF. So it will be loading state. Finally, the full state. Full state will nothing but, here is the state. Now neighborship form, all the routing table is established. Okay. So there is one more thing called router ID. How we can configure interface? Sorry, if you go router OSPF one, you can configure router ID here. Router ID 1.1.1.1. Okay. See, when we do it, we need to clear the IP OSPF process. See, it is saying this command to make it effective. Reload or use clear IP OSPF process. So what I will do, clear IP OSPF process. Reset all OSPF. You say yes. Now see, all neighborship will refresh. So now if you go and check, can you see what is the router ID now? Neighbor 1.1.1.1. So now they are in here. So if you go here and check, so previously what was the neighbor ID? This one. Now if you check now, can you see it become 1.1.1.1. So we need to clear the IP OSPF process. So what will happen? The neighborship will be get refresh. Okay. So this is just one thing which was missed yesterday. So I thought to give that detail. So these are the states. Okay. And routing the route table. See, OSPF. It first. Okay, internal router. Internal router means the router which are in area 0. They called internal router. Area border router ABR, the router which are connected in multiple areas, area 1 and area 0. So they are called ABR. ASBR, autonomous system boundary router, the router which are connected in multiple routing protocol. Yesterday we saw this one, this picture, this one. See, these are the router, backbone router. Internal, these are called, the A and B are internal router. C, D, and E, they are ABR. In like they are participate in multiple areas. And you know, if suppose F, G, and H, if they connected to another like routing protocol, that time they will be called as ASBR. We will see that ASBR. We will see when we understand the redistribution. That time we will see that. Okay. So for now we have seen the what is called area 0. So these are the router types. And OSPF maintain three tables: neighbor table, database table, and routing info, like routing table. Okay. So if you go here and check three tables. So US router, show IP OSPF neighbor. So it has two neighbors, right? So now you must know what is the router ID, why it is saying right now. because by default it pick the highest IP address. If you do the router ID in under the OSPF, then that time it will identify. So router ID is we use for the identification generally. So this is the one table. The next is show OSPF database. So database, it will have a complete entry of this one. This checksum, this sequence, and all are the much details in the database. And finally, show IP route. So this is the routing table, okay, where it get all the information. So three tables maintained by the OSPF. Okay. So OSPF, we have the what is called area concept. Okay. Now let's see the EIGRP. Okay, what is EIGRP? Enhanced Interior Gateway Routing Protocol. Okay, it is a Cisco proprietary protocol. Cisco proprietary protocol means it support on Cisco only. Then, okay, now this is the one. Do you see this advantage or disadvantage? The first point. This is a disadvantage. Next, classless routing protocol. See, classless routing protocol we discussed. Classless means it support the subnetting. Next, include all feature of IGRP. So you know the EIGRP is nothing but there was one protocol in the start that is IGRP by Cisco. So it was dead. So after that, Cisco came with the enhanced interior gateway routing protocol that is called EIGRP. Okay, and the metric. See, metric is very important. Metric is, for RIP, the metrics are nothing but the hop counts. Okay, in the OSPF, the metric is nothing but the what is called bandwidth 10 to 8 by bandwidth, right? Then here the metric is nothing but combination of bandwidth plus delay plus load plus MTU plus reliability. Okay, so it is a composite metric. So metric means the distance, how it calculate the distance. So it calculate by bandwidth, delay, load, and MTU and reliability. Okay, this combination. So routing protocol does the metric with this. Administrative distance is 90. Okay, updates are through multicast. See, multicast. This IP address is reserved for OSPF 224.0.0.5 and 6. These two IP addresses are reserved for OSPF. For RIP 224.0.0.9, that is reserved for RIP version 2. And this for EIGRP 224.0.0.10, it is reserved for the EIGRP multicast. So only the EIGRP to EIGRP router, the router will exchange. See, the broadcast means it will send to everyone. Multicast means only to the specific people. Okay, maximum hop count is 255. RIP was having hop count 16. OSPF was having unlimited. It is having 255. It support IP, IPX, Apple Talk. Hello packets are sent in every 5 seconds. See, every 5 seconds, hello packets are sent, and conversion rate is very fast in EIGRP. We will see the difference now. First release in 1994. See, iOS came with 9.221. It support VLSM CIDR. It is a dual diffusion update algorithm. See, dual algorithm. It used the dual algorithm. OSPF used Dijkstra algorithm, and RIP used the Bellman algorithm. Summarization can be done on every router. Summarization means this is something very advanced level thing. Summarization, it is summarization. It is used to reduce your routing table. See, currently, let's see, you see this many route. So if you increase your network, so the route will be this much. If you increase some route, so the routes will be thousands of routes. So you can reduce the route by using the summarization. We use the summary, we do this. For that, you need to know the subnetting. So we will do, like, instead of this, we will put some /20. So all the 192.168 those will cover in that one. So it is nothing but the summarization, and it support constant and unequal cost load balancing. See, OSPF support only the equal load balancing, but it is unequal load balancing. It support and it maintains three routing table: neighbor table, topology table, routing table. Remember, OSPF maintain neighbor table that EIGRP also maintain. RIP maintain EIGRP neighbor table? No. OSPF maintain database table. RIP maintain database table, and EIGRP maintain topology table. And routing table is a common for all. Okay. So and disadvantage of EIGRP work only on Cisco router. That is only the disadvantage. And EIGRP table and terminology. See, in the EIGRP, a routing EIGRP maintain three tables: neighbor table, topology table, and routing table. Okay, neighbor table. See, R1 it will maintain I connected with R3, R4, and R2. So this is my neighbor table, right? Topology table. When they become a see, first they build a neighbor table, then in topology table, see R3, what R3 will say, R3 will, when they become a neighbor, R3 will send his all entire route to R1. Similarly, R4 will send entire route, all the missing route, and R2 will send. So all the information will have to the R1. So R1, for based on this the routing table, it meant it prepare a topology table. Okay, and finally from the topology table it filtered, and this will be a routing table. So the routing decision will be taken by this particular table: neighbor table, topology table, and routing table. Okay, so EIGRP is, it is nothing but the in short, if I say, it is having all the what is called positive points of RIP, the easiness of the RIP, and the advanced thing of the OSPF. And EIGRP become very very popular. And if there is a Cisco or environment, then you will not see OSPF here. You will see EIGRP here. But in the case you have multiple vendor, that time you will see the OSPF. Okay, so EIGRP is one of the big very famous routing protocol and very easy. See, in the OSPF you need to maintain the area concept and all, but EIGRP there is nothing. Now we will see the EIGRP configuration now. Okay, so let me remove my OSPF. How to remove? No router OSPF process 1 done. OSPF remove. If I go here in US router config terminal, no router OSPF 1 done. OSPF remove. OSPF remove. Now config terminal, no OSPF, sorry, no router OSPF process 1 process ID. So now our diagram is empty now. Okay. So how to verify empty diagram? Show IP route. See, I have three connected route. Do I see the R symbol or O symbol here? R means OSPF. O means OSPF. R means RIP. But what about the EIGRP? What EIGRP will say? D. If you see the D route, D symbol will be the EIGRP routes. Okay. So now let's configure the EIGRP. So the ultimate goal is this one. What is the ultimate goal? If I go here, so can I ping 30.10? No, there is no destination. Umar, can you tell me why I'm unable to ping from India land to UK land, and why I'm unable to ping? And what is mean by destination host unreachable? What does it mean?
It is not able to
Gateway.
ping the destination.
Okay, perfect. So if I do the trace route, see, the first thing first, it is going to the gateway. Gateway is nothing but the router. And router is saying destination host unreachable. You want to go to 30.10. 30.10, it is not in my routing table. Where is my 30.10 here? Nothing. I don't know. That's why the routing protocol is required, right? So now we will go and configure the EIGRP. Config terminal, EIG router EIGRP. See, in OSPF we use the process ID. Here we use the autonomous system. So this is just a number. So I'm using the router EIGRP one. Done. Now network 192.168.10.0. Finish. 192.168.1.0. Finish. Can you see? Is it look like a it look like a RIP? Am I right?
Yes.
Yes. So no need to mention the no need to mention your area and all. Okay. Now this is good done. So now just watch here. Okay. Now I'm configuring on a USA router. Router EIGRP network LAN 192.168.20.0, then 2.0. Now can you see how faster protocol it is? See, now I'm just enabling the WAN link. Can you see in the fraction of second the neighborship got formed? Do you see this faster in the RIP or OSPF this much faster? Do you observe this one? No. In OSPF at least it will take some more seconds. Okay, now see here. Config terminal router EIGRP 1 network 192.168.30.0. Okay. Now see when I'm enabling the my WAN link, can you see how quickly it is like a rapid fast spanning tree? You just remember that one, rapid fast spanning tree. So now I have the neighborship. Okay. So now I'm in the user router. Show IP EIGRP first neighbor. Can you see again the neighborship 1.1 2.2 neighborship got formed. It will tell you the uptime, hold, and all. Okay. Similarly, show IP EIGRP topology table. See, in the topology it will have passive and active, passive route and active route. So successor and diffuser. Some more concepts are there. Successor. Can you see FD? So these are very advanced things. Next, show IP route. Can you see the route came? So if I say show IP route EIGRP, can you see these two routes came from here? 192.168 10.10 D 10 and 30, right? Similarly, if I go here, okay, can I is I am able to ping? Yes, I'm able to ping. And what about the trace route? Same. See how fast it is going. So just let me just show you the comparatively how fast, quicker this will be. This is my it's called India router. This is my UK router. Okay, so now I'm doing it. Okay, now if you go here, show IP route EIGRP. Okay, so here you can see the 10.0, which is nothing but our India LAN. So I'm going to shut down the India LAN. On the terminal interface, GUI connect 0 by shut down. Can you see here? See my 10 route missing. How quickly it happened. See when I say show IP EIGRP now, I have 1, 2, 10. Oh, sorry. See here is the command. Show IP EIGRP. So when I said after that 1, 2, and 20 only. Where is the 10? Where is the 10? 10 gone. Similarly, when I say no shutdown, see now just go here and put again. Can you see 10 came back? See how quickly it's happening. Can you see the 90? 90 means what? Administrative distance. How quickly the neighborship form, right? So similarly, okay. So let me. Okay, now USA router. It is the Okay, let me on the USA router and let me shut down its interfaces. Now you can see how quickly it will see the neighbors. Okay, what I'm doing, config terminal interface. Okay, let me advertise that loopback address of the USA, show IP interface grid. I created one loopback 100.0. Remember that. So now I'm advertising it in the EIGRP. EIGRP router, EIGRP 1 network 192.168.100.0. See, until just I advertise in fraction of second, you can see here. Can you see 100.0? It came here. Similarly, if you go here, so IP route EIGRP, can you see 100.0? See, I'm just removing it again. I don't want this. I don't want to advertise this. No network. Now just go here. Check here. Can you see? Just go here and check. Can you see 100? See, it is happening rapidly, rapid fast. You remember that rapid fast spanning tree. So with that, what was happening? So your interface was shutting up and down very quickly, port fast. If you remember that, recall that. So this is what the EIGRP. So now tell me, now question to you guys. Now question to you guys. RIP, OSPF, EIGRP. Which one is good? Looks good to you?
AIGPR.
OSPF.
Okay, one said EIGRP, one said
OSPF.
OSPF, and what?
Handson.
And what another one? Umar? Hello? You know, whatever the the RIP configuration was very easy. Okay, just advertise the network. But in OSPF, you have the complexity, area. You need to remember the area. Every router should be connected to backbone network. Okay, there is some complexity. Okay, and the advantage RIP was slow, OSPF was very fast. But EIGRP, it is don't have area concept and it is super fast. So if you have a Cisco environment, then EIGRP is the first preference. And if you have a mixed environment, then OSPF is first preference. Okay. And RIP, I never saw RIP is used anywhere. Even version 2 also, it has version 1. Version 1 is actually it is dead. And version 2, actually version 2 has the advanced features, but still I never saw RIP version 2 used in my career. I never saw it used. So the two and static and default, these are used on day to day. Static, see, it will use everywhere. Default use everywhere where the internet, and this is your choice where you have. So this is a hard. So configuration is very simple. See, if I show the configuration RIP. Okay, so what I need to do, router, I just need to go say router RIP. Okay, under that I just need to advertise network 192.168.10.0 and another one network 192.168.1.0. Done. This is only the configuration you have. OSPF. Router OSPF process ID 1 network 192.168.20.0, then 0 dot some your wildcard mask 255, then area, mention the area 0. Area 0. Similarly, you can copy it. Into 168, your ISP1, then your ISP2. Done. See, always we need to comparatively, as I told, comparatively study of the routing protocol. EIGRP. Okay. Router EIGRP and autonomous system. Network 192.168.30.0. 192.168.20.0. Actually, what this is nothing but my I configured on India router. This is my USA router, and this is my UK router. Now, by looking the configuration, can you tell me which one looks easy?
EIR.
Exactly. And which one is the faster? Super fast.
EIRP.
EIG pure.
Exactly. So EIGRP, sorry, is EIGRP. EIGRP, Enhanced Interior Gateway Routing Protocol. So EIGRP win. Because why? Because speed, it gives the speed plus easiness. EIGRP win, but only the disadvantage. It supports the system. Got it? So this is something. These are the commands which we use in our day-to-day life. And what are the commands? Commands are very simple. If I go here for the yeah, see, show IP route is the basic command everywhere. Show IP route. Then show IP RIP database. This command is used. Then if I go here, OSPF, show IP route is a basic command. Then show IP show IP OSPF database, right? And another one is show IP OSPF neighbor. So this is actually the recap of what we have seen, right? And here, what are the commands here? Show IP route is the basic command. Show IP EIGRP neighbor and show IP show IP EIGRP, right? So these are them. And apart from this, we can use some debug command. You remember in RIP we used the debug command. Yesterday we used the debug command. Debug command is nothing but it will tell you the logs. Okay, let's say I'm in the UK router. Okay, debug. Can you see? You can if you say eigrp, debug eigrp, then debug IP, see OSPF and RIP. So you can put this debug. Let's say right now eigrp you're using, right? Debug eigrp. Put the question mark packets. Oh. See, in the real time, if you put the debug is used for the troubleshooting. So if you put the debug, so router CPU utilization will be high. So don't use in the real time. It's very rare at the time of what is troubleshooting only we use. So let me shut down the US router. Link of the US router. You know, see here. I'm here. Config terminal. Interface first Giga Ethernet 0 by. Now see, when I do shutdown, something happen here. Protocol down, on relay. Flags, some flags will be missed here. Similarly, when I say no shutdown, so no. See, the update came, acknowledge, hello, and all. So see, it is very useful for the troubleshooting. So let's say in the EIGRP router EIGRP1. Okay, if I use some feature, see these are some advanced feature which we use in CCNP level and all. But I'm just showing you something like neighbor neighbor address is, let's say uh, to show EIGRP IPIGRP. Okay, 2.2. So router EIGRP1 neighbor 192.168.2.2. Sorry, go back feature actually. Hmm. Okay, no problem. So I think this router don't support that. So I just wanted to show you. Okay, see, can you see when you on the debug and you left right? So like this continuously router will see all the stuffs. So always you need to say you you debug undebug all. See, undebug all. Then only it will turn off. Otherwise, the key packets will come and CPU utilization will high. And when the router shut down, you will ask why it was down. Oh, debug was on. So debug is used for troubleshooting command. So what is the troubleshooting command? Debug. But you can try on the packet tracer. Debug IP, debug IP, RIP packets. Similarly, here also for the OSPF we use debug IP OSPF adjacency. So, and in EIGRP we use debug EIGRP what was that? Debug EIGRP This is the command we use for the debug. But be cautious while using the this one. Okay, so okay, so now we know all are the dynamic routing protocol. Okay, all these three are dynamic routing protocols. Protocols means what? Protocol means nothing but it is a set of rule. Okay, it is a set of rule, and every routing protocol has its own route, its own rules, right? So dynamic protocols, like RIP comes under distance vector protocol. This is a link state protocol. This is a hybrid distance vector. Okay, so I have something here comparatively. So let's see here. Let me take this in the pen and so that I can use the. Guys, you with me? Hello, everyone there or sleeping?
Yes.
Because afternoon time is, I know, but this is important. Okay, so new. Let me take here. Don't save. There we go. Okay. Now, okay, now see here. RIP version 1, RIP version 2. Okay. Then OSPF, then EIGF. So this table is very useful. I use for the interviews. Okay. Name. RIP means routing information protocol. RIP means routing information protocol version 2. OSPF open shortest path first. Enhance exterior gateway routing protocol EIGF. Protocol type. See it comes distance vector protocol. This is also distance vector protocol. OSPF is a link state protocol, and EIGRP is a hybrid protocol. See, it is also called advanced distance vector protocol (ADV) because whatever the RIP features. So what EIGRP is nothing but the combination of positives of RIP and positives of OSPF. Nothing but the EIGRP protocol. This is a standard protocol. Can work on all standard, but this is the Cisco proprietary EIGRP. Metric, this is very important. Metric, how the metric calculated. Hop count, so here the hop count set, hop counts are 16. Here also hop counts are 16, only 16 routers. Okay, but here it is calculated on the cost, unlimited cost, and here the bandwidth plus delay, it used the bandwidth plus delay as a metric. Hop count, maximum hop count 15, 0 to 16 means 15. Here unlimited, it is used for the larger network. There is no dependency. But EIGRP used for the 255 limitations. Administrative distance. See, this is very important. 120 EIGRP, RIP, 120 RIP, 110 OSPF, and 90 for the internal and 170 for the external in EIGRP. External, again, when we do the redistribution, that time the external it will show the external routes. Okay. Update timer every 30 seconds. See, every 30 seconds router will go, they will extend the routing table, entire routing table in both the RIP version 2. But here trigger update, whenever something change, something down, something added, then only the trigger update. See, triggered something update. Okay, any new information, then only they will trigger. Update type, how this routing protocol update, it use the broadcast RIP version 1, hello to all. But RIP was having multicast 192.224.0.0.9. See, multicast OSPF use 5.6, I told you, and multicast here. These IPs are reserved. So by using, whenever these routers are, let's say they are in connected to OSPF, so they use this IP address 192.160. It's 224.0.0.5 multicast to talk to each other, to send the updates. They don't use anything. So the The advantage of the multicast, let's say you have some another router here, which are not participating in the routing. Maybe it is participating EIGRP, maybe it is participating static route. So only these are participating OSPF. So it will just pass the updates to this guy. It will not pass here and here. So that's the advantage. Multicast. Scalability, no scalability. So it is there is no future. Scalable, yes, it can be scalable. Like you can extend your network. You can extend your network. Authentication, it does not support authentication. You cannot see authentication means while routing protocol when you update, so we can use the authentication like password we can put. So if the password, if you put, like if you remember in if you use the password, then only it will become a neighbor. So password we will it will use. So RIP version 2, open shortest path, and EIGRP both use the all three can use authentication. Load balancing, equal load balancing, equal load balancing, equal load balancing, equal and unequal. Equal load balancing means if suppose you have to reach one destination, you have two routes, two paths from here to here and here to here, this direction or this direction. So this is called equal load balancing. Okay, but EIGRP support unequal load balancing. Conversion, see it is very slow. This is very slow. OSPF is fast, and I can say this is super fast. EIGRP. And VLSM like subnetting, it is a classful. It supports the subnetting, it supports the subnetting, it supports the subnetting. That's it. So this is a comparatively study of your all three routing protocol. RIP. See, whenever I say RIP, use the version 2. Version 2 means you just need to add one command into version 2. RIP and RIP version 2. Okay. So what you need to do, like see, just use this topology, just remove and configure one by one. RIP, OSPF, and RIP. It will not take much time. It's very simple and very easy. Any questions? Any questions?
No question.
Okay, perfect. So, okay, guys. So we'll stop here. So please do the practice of all three in comparatively. And I have sent you this document. So just remember this one. And in next few lectures, again we are going to repeat this because our next topic is ACL. Then we have the redistribution. So those things again we need to that will run on top of this routing only. So we need to build the routing. Then we will use the security. ACL again. If you
Most
don't,
of the ERGP are using in your organization.
if it is a Cisco, if there is a Cisco
If it
environment,
is
then
Cisco probably.
EAGRP. If there is a mixed environment, OSPF.
Oh, SPF.
Okay, so guys, please do this lab. See, only the practice will take you to the next level. Otherwise, you have the YouTube video. You can watch this video in number of times. Yeah. Yes, right. We are ending this meeting.
We have 4 minutes.
Okay, fine. Okay, guys. So please do the practice and do first do the RIP. Just first build the lab, the same lab, save it. Then build the RIP, test the RIP. Like all commands go here and check the routing table and database table. Ping from here to here and shut down one network and see here how much time it's taking. RIP. Then do the version 2. Okay. Then do the OSPF. Then do the EAGR. Just remove the configuration and do it. Use it again. Okay.
Yeah.
So okay, we will see you tomorrow. Bye.
Okay, so,
Bye.